Okay, find the center, foci, vertices, and eccentricity of the conic section and sketch its graph given the following equation. Well, what are we going to do here? We should complete the square on both x and y. And to do that, I should write this as, I should write this as 4y squared. Oh wait, that's already together. I was going to collect my x and y terms, but they're already collected. My bad. So what I want to do then is I want to factor out that 4 from my y squared. What am I left with? Well, I'm left with y squared plus, let's factor the 4 out of that 40y to be left with 10y. Let's think real quick about how we would complete this square. Well, to complete this square, we would need half of that middle term squared. Half of 10 is 5. 5 squared is 25. So we added that right there. Plus, let's factor out that 9, and what are we left with? Well, x squared minus, well, what's 54 divided by 9? 54 divided by 9 is 6, so x squared minus 6x. And then in the same way, let's go ahead and complete the square. Well, what's half of negative 6? Half of negative 6 is negative 3. What is that squared? Well, negative 3 squared is positive 9, so plus 9 right there. Now we've completed that square. And let's say equals, now I'm going to subtract that 37 over to the other side, and I need to balance my equation because here I added that 25 times that 4, which means I need to add 25 times 4 over there. And in this completed square, on my x term, I added 9 times a positive 9, which means I need to add that over here. And now I can go through and simplify things, and I can figure out what this number is. And I'm going to use a calculator because I'm feeling like just cruising. So when you crunch all those numbers, you should find that negative 37 plus 25 times 4 plus 9 times 9 is 144. And so what should we do with that? Well, we should divide everything by 144. So I'm going to divide all of these pieces by 144. Notice I'm only writing it underneath those numbers because, you know, multiplication, division, they're all the same thing, and you can do them in any order. So there you have it. Well, what is 4 divided by 144? Well, if you do 4 divided by 144 in your calculator, you're going to get an ugly decimal, 0.027 repeating. And maybe if this were next unit, I could teach you how to figure out what that is using a sequence, but we don't know how to do that yet. So you could hit Math Frac if you're using a TI calculator, or why don't you try this? Why don't you do 144 divided by 4? 144 divided by 4 is 36, which tells me that I'm going to end up with this completed square for y, which is y plus 5 squared, over 4 over 144 gives us a 36 in the denominator, which I will write as 6 squared, plus 9 over 144, or 144 divided by 9, will give you 16, which is 4 squared. So I will write this completed square as x minus 3 squared over 16, which is 4 squared, equals 144 over 144 is 1. So I have there the equation of my ellipse. I want to find the center. Well, the center is going to be the point with an x value at positive 3 and a y value at negative 5. I need to find the foci, which means I need to find my c value. Well, what do I know? I know that a squared equals b squared plus c squared. So I need to figure out what the square root of 6 squared minus 4 squared is. And that will tell me what c is. Well, 6 squared is 36, 4 squared is 16, 36 minus 16 is 20. So I know that c is going to be the square root of 20, and 20 is 5 times 4, so I can simplify this to 2 times the square root of 5, because the square root of 4 is 2, so I can pull that out front. 2 times the square root of 5 is my c value right there, which means if I want to find the coordinates of the foci and the vertices, I gotta do a couple things. First off, I need to recognize that my ellipse will be oriented vertically, since the larger denominator is with my y term. So that tells me the x value of the foci will remain the same, because they will be in line. And so the x value is still going to be positive 3, comma, what's the y value going to be? Well, it's going to be the y value of the center plus or minus that c value, which we found to be 2 root 5. So there you go. There are my vertices. Let's do something similar with my vertex. The vertex is going to have, again, the same x value there, and it's going to be the center, negative 5, plus or minus my a value, which is 6. So we get that right there, which you could be not lazy and write as 3, comma, negative 5 plus 6 is positive 1, and a second vertex at 3, comma, negative 5 minus 6 is negative 11. It's just a little more clear that way to know really where we're looking. And so what else do we need to do? We need to find the eccentricity of this conic section. So remember, the eccentricity is c divided by a. So in this case, the eccentricity is our c value, 2 root 5, divided our a value, which is 6. So we can write this as root 5 divided by 3, simplifying that 2 over 6. And we can figure out an actual approximation for this. And if you crunch that number, you should find that the eccentricity is 0.745. So remember, if that eccentricity were 0, you'd be talking about a circle. And if the eccentricity were 1, you'd be talking about a line. Picture like a super skinny ellipse like that. And so that 0.75, that's pretty high up there, which tells you that this ellipse is fairly elongated like that. So let's sketch this real quick. So let's draw our axes. Where's our center going to be? X is going to be 3, y is going to be negative 5. So I'm going to plot this like that. Let's go ahead and say 1, 2, 3. Ooh, and let's go 1, 2, 3, 4, 5, and let's plot that center. And this is how I like to graph my ellipses. I'm going to say, hey, look at that 6, it's underneath my y. Let's go from that center point up 6, which is going to put me up here, and let's go from that center point down 6. So let's go 1, 2, 3, 4, 5, 6, and we're down right there. And then look at that 4 underneath your x term. That's telling me to go 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left to get my co-vertices right there. And now I could draw in this ellipse like that. Kind of lumpy looking, but it's all basically there. You could double check and notice that, hey, the vertices that we calculated using algebra are actually where they are when we just counted going up and down. And so where are my foci? Well, 2 root 5, let's figure out what that is approximately. Well, 2 root 5 is approximately 4.5, so that tells me that if I go up 1, 2, 3, 4.5, that should be one focus, and I go down 1, 2, 3, 4.5, there should be another one right there. So there is my lovely ellipse. Found my eccentricity right there, telling me that it's pretty elongated, which you might be fooled by my drawing because my scale again is not super accurate. But there is my equation in rectangular form, and I think that's pretty much everything it asks for.